All right, this video we're going to look at normal distribution, and it's going to be some word problems where we actually find the percentage underneath the curve and all that stuff. The video before this one, it was normal distribution, but it was kind of, I guess you could say, special cases where we were 1, 2, or 3 standard deviations about the mean. We didn't have to look anything up in a Z table. But this video, the Z values are like this one, 0.8. We're 0.8 standard deviations from the mean, or 1.3 standard deviations above the mean or below the mean or about the mean. Okay. In the last video, we were either 1 standard deviation, 2, or 3 standard deviations from the mean. So that was a special thing. That was the empirical rule. And you could get those same values where we used on the empirical rule. You could get those same values from the way we're going to do it in this video by having to look it up in a Z table. All right, so let's go ahead and get started. So it says find the percentage of data items that lie below Z equal 0.8. All right, so whenever you're working these, draw the picture. Okay, draw the picture. So we've got our normal distribution, and we know that these are Z-scores. So we're on the standard normal curve where the mean is 0 and the standard deviation is 1. And so the 0.8 would fall here. And we're looking for the area below. So it's this area right here. All right. Now, we've got to look this up in our table. So you can see here we have a positive Z-score. And so we're going to come to the table that has the positive Z-score. Now, there's different tables out there. Some books use, they're kind of the same, but there's, in some books, there's a table like this one that when you look up the Z-score, when you look it up, it gives you the area to the left of the Z-score, like this one. See, I'm going to show you how to look up the Z value. But when you do look up the Z value, the area that it gives you is to the left of the Z value. Now, there's other tables out there. Like if you have this and you have a Z-score, when you look up the Z-score, it just gives you the area back to the mean. Okay. Now, as far as how to read the table that does this, I have a video on my channel, how to read 2 different Z tables. Just search for that on my channel and it goes over both of them. But for this one, I like this table better, but if you have to use the other one, just go look up that video and you can see how to do it. So we're looking for, to the left, I'll draw it here again, of 0.8. So we're looking for this area right here. Okay. So we've just got to look up 0.8 Z-score, and then we've got the area. So the Z-score, here's your Z values, your Z-scores on this first column here. See Z, and then these up here also. So let me explain to you what this means. Let's just go down here to this 1.5. So this is 1.50. This is 1.51, 1.52. Okay. What this row across the top does is that gives you the second decimal place. Okay. So, and then like this one, this is 0.50, 0.51, 0.52. Okay. That's how you look it up. And then there's another table. There's a second page with negative Z-scores on them. We'll look at that in the video also. But for this one, we've got to look up 0.8. So when we look up 0.8, you can see here's the 0.8, and we need 0.8 0, right? That's understood to be a 0 there. So 0.8, and then the second decimal place is 0. So it's where these two cross. And so that's our answer, 0.7881. And so this would be 0.7881. And there's your answer. All right. Now let's look at this one. Above 1.3. Above z equals 1. I didn't put the z, but it's above z equals 1.3. So let's draw it. So there's 0, there's 1.3, and we're looking for the area above that. Okay, so let's come back over here to the table, and we're looking for 1.3. So there's 0, there's 1.3, and we're looking for the area above. Now, remember, whenever we look up the z value, that gives us the area to the left. That gives us this area over here. But we need the area over here to the right. Well, the area under the entire curve is 1. Okay, the area under the entire curve is 1. So if we know this area, so in other words, let's just say this area is 0.6. Then that means this area would be what? 0.4. 1 minus 0.6, which is 0.4. So what we do is we look up the 1.3, and that gives us the area to the left. So 1.30, right? 1.30, that's 0.9032, 0.9032. That's the area. That's this area right here, the 0.9032. So to find this area to the right, that would be 1 minus 0.9032. And so that would be 1 minus 0.9032. That is 0.0968. And this would be your answer. Okay. See, in the video before, we just knew what it was from that empirical rule. Okay. All right. Now let's look up the negative. We've got some negative z values here. So let's draw the picture. So we've got 0, negative 0.67, because negative's to the left of 0. And we're looking for this area right here. So all we have to do is go look up negative 0.67, and that's our area. So let's come over here, and we need to go to the negative z table. So we're looking for negative 0.67. So there's negative 0.6. See the negative 0.6 right here. And the second decimal place is a 7. So we've got to come all the way over to this column. And it's going to be, there's our area. So 0.2514. So that's going to be 0.2514. That's the area. All right, so let's look at this one. There's 0, there's negative 1.35, and we're looking for the area above. So it's that one. So remember, when we look this value up, that's going to give us the area over here to the left. To the left over here. Let me do this in a different color. That's this area here to the left. That's what it's going to give us when we look the value up in the table. So we've got to do 1 minus this area to get this area. Okay. So let's go look up negative 1.35. So negative 1.3, and then we need to be in this column for 3.5. So it's where these two intersect. So that's 0.0885. 0.0885. So we've got 1 minus 0.0885. And so this is going to be 1 minus 0.0885. And that is 0.9115. And there's your area. Okay. All right, so this is the last one looking up. So we're looking up between two values. So let's draw our picture. There's 0, there's 0.3, and there's 2.1. And so we're looking for this area right here that's between them. All right. So now if you look at this, if we look up the 2.1, that gives us the area to the left. If we look up 0.3, the 0.3, that gives us the area to the left of 0.3. Well, look at this. If you take all of this area to the left of 2.1 and you subtract off this area to the left of 0.3, you subtract all of this off, see, that just leaves us with this area in between. So we look up the value of 2.1, we look that area up, and then we look this area up and we subtract the two. So it's the area of this one minus the area of this one. Okay? So let's go look up we need to look up 2.1 and 0.3. So we need to look up 2.1 and 0.3. All right, and I'm going to draw it here, and we'll just work the problem here because save me from having to flip back and forth. So this is the area we're looking for. So I need 2.1, so 2.1, that is going to be 2.10, right? There's a 0. So it's going to be this value, which is 0.9821 minus, and now I've got to look up the 0.3. Well, there's 0.30, so I'm in the first column, and so I've got to subtract off 0.6179. And so that is going to give me 0.9821 minus 0.6179, and that area is going to be 0.3642. That's a 3. And that's your answer for that problem. Okay, so hopefully you understand how to look these up. If you understand how to look these up, then the problems that we're going to be working, they're easy to do. Okay, the only thing is they give us the data item, and then we have to convert it to a z-score or a z-value, and then look it up in the table, and that's really all we're doing. So let's go ahead and get started on the application problems. All right, so if you recall from last time, we've got this property right here. So to convert a data item to a z-score, the z-score is the data item minus the mean divided by the standard deviation. Okay, we've got 3 examples to work. All right, so it says, according to the Department of Health and Education, cholesterol levels are normally distributed for men between 18 and 24 years. The mean is 178.1. So the mean is 178.1, and the standard deviation is 40.7. What percentage of men is in this age range have a cholesterol level less than 139.15? All right. 239.15. So look, just draw a picture. Okay, so the mean is 178.1, and we've got 239.15. Okay, and we want to know have a cholesterol level less than this. So we're looking for this percentage here, or this area. All right. Now, remember, in the standard normal curve, which is this, see, standard normal distribution, that's this thing right here, okay? Our values have to be z-values, or z-scores. That's the ones we can look up, okay? Now, do you have to look them up in that table? No. There is other ways you can do it. You can do it with calculus, but it is very, very, very difficult to do with calculus, okay? So that's why we have this, that we can take the data item, which is this number right here. That's our data item. See, these values here, the 178.1, the 239.15, and the 40.7, that's what we're going to use to convert it to a z-score, so we can look it up in the table rather than having to do it with that very complicated formula from calculus. Okay, so the first thing we have to do is we have to calculate our z-score. So our z-score is, remember, the data item. So the data item, that's what we're comparing. That's this 239.15. That's 239.15 minus the mean, which is 178.1, over the standard deviation. Okay, so we did this in the previous video, converting to a z-score. Okay, that's nothing new. The only thing that we've learned new in this video is how to look the values up in the table. So what we're doing is we're just taking that, converting to a z-score, and looking it up in the table. We're just combining that into one problem. That's all you're doing. Okay, and when you calculate this z-score, you get 1.5. Okay, so if we convert this to the standard normal curve, remember the mean is 0 and the z value is 1.5. Okay, and so we converted this 239.15 to a z-score. So now all we have to do is go look up the 1.5 in the table. Okay, that's what this is for. Is so that we can look it up in the table to find that percentage we want. Okay, so if I come over here, now I just got to look up the 1.1.50, right? So that's 0.9332. So 0.9332. So that is going to be 0.9332. All right. So what does that mean? That means 93.32% of men between ages 18 and 24 have a cholesterol level less than the 239.15, and that's what that means. Okay. All right. Let's look at the next one. Lengths of pregnancies of women are normally distributed with a mean of 266 days and a standard deviation of 16 days. What percentage of children are born from pregnancies lasting more than 274 days? Okay, so draw it out. Just draw it out. All right, there's zero. I'm sorry. Let's label this. The mean is 266, and we're looking for 274, so that's above. And we're looking for lasting more than 274 days, so we're looking for that area there. And we know the mean is equal to 266, and the standard deviation is 16. All right, so we've got to convert this to a z-score. So our z-score is going to be the data item, which that's the 274, minus the mean over the standard deviation. Okay. So like I said, it's just converting it. Okay, you just got to convert it. So that comes out to be 0.5. And so remember, in the standard normal curve, the mean is 0 and our z-score is 0.5. So that's what we're going to look up for the 274. We're going to look up 0.5. So let's go look it up. So we look up the 0.5. So there's 0.5, and we're looking up 0.50. Okay, first column, 0.6915, 0.6915. So 0.6915. But remember that 0.6915, that's this area to the left. Remember the area the table gives you, that's the area to the left. And we need the area to the right. So we've got to do 1 minus that. And when we do that, that comes out to be, let's see, 1 minus 0.6915, that comes out to be 0.3085. And so we're at 30.85%. All right. So that means 30.85% of children are born from pregnancies lasting more than 274 days. And that's your answer. Okay. All right. So this one is the last problem. All right. So the amount of time that self-employed Americans work each week is normally distributed with a mean of 44.6 hours and a standard deviation of 14.4 hours. What percentage of self-employed individuals in the U.S. work between 37.4 and 80.6 hours per week? All right, so once again, draw it. So our mean is 44.6, and we want to know between 37.4 and 80.6. This is the percentage we're looking for between those two numbers. And see, we already know how to look it up when we already know how to figure it out when it's between two numbers. We've got to look up this one and then look up this one and subtract them. But first, we've got to do what? We've got to convert each of those to a z-score so we can look them up. Okay? All right. So let's look up a z-score and let's look up the z-score for 37.4. And I'm going to put the subscript 37.4 so we know this z-value goes with this one. And so, well, first, before we do that, let's write down the mean is 44.6. Standard deviation is 14.4. And so now z 37.4, that's going to be the 37.4, the data item, minus the mean over the standard deviation. And when we punch that into our calculator, we get negative 0.5. And then let's calculate the z-score for 80.6. Okay, that's for this one. And I'm just putting these subscripts so we'll know which one's which. And so it's the data item minus the mean over the standard deviation. And so this z-score is 2.5. So remember, on the standard normal, the mean is 0. This z-value is 2.5, and this z-value is negative 0.5. So I've got to look up these z-values. And so first, let's look up the 2.5. And so 2.5 right there, 2.50, so it's this one, 0.9938. 0.9938. So 0.9938. That was this one. Now I've got to look up this one and subtract it. So let's look up the negative 0.5. So negative 0.5, let's see, there's negative 0.5 and 0, so 0.3085, 0.3085, 0.3085. And then when we subtract the two, we get 0.9938 minus 0.3085, and that is equal to 0.6853. So that's 68.53%. Okay, so 68.53% of self-employed Americans work between 37.4 and 80.6 hours per week. Okay, so that's what we were finding. So, you know, that's how you do this. And look, like I said in that last video, we used the empirical rule, but if you go look up those values in the Z table, you'll get the same answers. You know, look up Z equal 1, Z equal negative 1, and subtract the two and see what you get. All right. It's just that in these problems, we're not one standard deviation from the mean. We're not two standard deviations from the mean. We're not three standard deviations from the mean. You can see we're 2.5 or negative 0.5 or, you know, 0.5 below the mean. You know, it's these odd values instead. Okay. So I hope that video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.